AI, and robotic integration. With recent breakthroughs in AI development, the idea of machines replacing humans in certain tasks is becoming more and more likely. From automated warehouses to self-driving cars, AI combined with robotics is already making its way into industries across the globe. But what if, instead of replacing humans, AI and robots could work alongside us, enhancing our physical abilities and giving us superhuman capabilities? This vision of the future, where humans and machines merge, is something we've seen portrayed in countless sci-fi movies, where cyborgs walk among us, blending human intelligence with robotic strength. But what if we're not far from seeing a real-world version of these enhanced beings? Perhaps we can catch a glimpse of this future by looking at the latest technology in exoskeletons. These robotic suits literally transform the wearer into a half-machine, augmenting strength and mobility in ways we never thought possible. The best part? They're becoming so practical that you can now buy them online for everyday use. The evolution of robotic exoskeletons, from sci-fi to reality. The concept of robotic exoskeletons has long been confined to the realm of science fiction, but recent innovations are bringing this once fantastical technology into the mainstream. These wearable robotic suits, which augment human strength and mobility, are becoming more sophisticated and accessible, offering new possibilities in healthcare, rehabilitation, and even enhancing athletic performance. In this video, we explore the exciting development of exoskeletons, showcasing real-world applications from their use in helping paralyzed individuals regain mobility to assisting athletes in achieving new physical feats, helping the paralyzed stand and walk again. One of the most groundbreaking applications of exoskeleton technology is its use in helping paralyzed individuals regain mobility. A recent example comes from the Phoenix robotic exoskeleton, which allows individuals with spinal cord injuries to stand up from their wheelchairs and walk. The Phoenix exoskeleton has already transformed the lives of many people with disabilities, giving them the ability to move independently, increase blood flow, and even reduce the discomfort that comes from prolonged sitting. In one demonstration, a paralyzed man shared his experience of using the Phoenix exoskeleton to walk again. He described the profound relief it provided, allowing him to stand and move, which helped with his circulation and physical health. The suit's modular design, with customizable parts like hip and knee modules, allows it to be adjusted to suit the wearer's specific needs, making it an essential tool for both rehabilitation and improving daily life for individuals with disabilities. Military applications, enhancing strength and mobility. The development of exoskeletons isn't limited to healthcare. Military forces have also been exploring their potential. Military exoskeletons are designed to enhance soldiers' strength, mobility, and endurance, allowing them to carry heavy loads over long distances and navigate difficult terrains. Some advanced models even integrate communication systems and weaponry. For example, the BLEEX, Berkeley Lower Extremity Exoskeleton Project, a collaboration between various institutions, aims to help soldiers carry heavy equipment without the risk of injury. By providing support for walking, running, and even crouching, these exoskeletons are designed to improve soldiers' performance while reducing fatigue and stress on the body. The modularity of military exoskeletons, much like the Phoenixes, allows them to be tailored to specific tasks, whether it's carrying heavy weapons or providing agility in combat situations. A historical overview. Exoskeletons in the 1960s. The journey of exoskeletons began much earlier than many realize. In the 1960s, General Electric developed one of the first wearable exoskeletons, known as the Hardiman. This early version was designed to augment the strength of its wearer, assisting them in lifting heavy objects. Though bulky and not very practical, the Hardiman laid the foundation for modern exoskeleton technology. Its failure was a result of its heavy weight and limited mobility, but it provided valuable lessons that would fuel future developments. The work done in the 1960s and 1970s paved the way for future innovations. As technology advanced in the following decades, exoskeletons became lighter, more flexible, and increasingly capable of enhancing human mobility. By the 2000s, research had shifted towards making these suits more practical for everyday use, including in rehabilitation and personal mobility. Exoskeletons for musicians, enhancing piano skills. In a more surprising application, robotic exoskeletons are even making their way into the world of music. A recent study published in Science Robotics explored how robotic exoskeletons can be used to help pianists improve their skills. Led by pianist Shinichi Furuya, the study found that using an exoskeleton designed to assist finger movements during practice allowed pianists to break through the plateau that many musicians face after years of training. The exoskeleton developed for this study uses passive assistance to support the movements of the pianist's fingers, helping them perform intricate tasks with less physical strain. The device was tested on 118 pianists, and the results were promising. After just 2 weeks of training with the exoskeleton, pianists showed significant improvement in both speed and accuracy, especially when performing technically challenging pieces like those by Chopin and Beethoven. This application of exoskeletons highlights the versatility of this technology. While traditionally used for physical rehabilitation, exoskeletons are now being explored in non-medical fields, such as enhancing the performance of musicians and other professionals who rely on fine motor skills. Advanced technology for civilian use and athletic enhancement. Beyond the battlefield and rehabilitation clinics, exoskeletons are increasingly being used in civilian life. For instance, the Densys X1 exoskeleton, designed to assist with walking, hiking, and running, uses artificial intelligence to predict and adjust to the user's movements in real time. This wearable suit learns how you walk and run, then enhances your performance by reducing fatigue and increasing efficiency. In a recent test, an athlete wore the Densys X1 while walking up a steep hill in San Francisco. Without the exoskeleton, the walk was strenuous, but with the device engaged at maximum assist level, the athlete completed the task 5 seconds faster. Although it didn't feel faster in the traditional sense, the exoskeleton made the process less exhausting, effectively reducing the amount of physical effort required. This subtle assistance is what sets modern exoskeletons apart from older models, providing support without feeling invasive or mechanical. The AI-powered Densys X1 is also notable for its lightweight design, weighing only 1.6 kilograms, and its ability to enhance running speeds. During a speed test, the wearer managed to run up to 19 kilometers per hour, which was notably faster than without the device. Though it didn't reach the 27 kilometers per hour claim, it provided a significant boost in performance, showcasing how AI can enhance human capabilities. The impact of AI in exoskeleton design. What truly sets the Densys X1 apart from previous exoskeletons is its use of artificial intelligence to adapt to the user's unique movement patterns. By learning the natural gait and stride of the wearer, the system customizes the support it provides. This is a far cry from earlier robotic suits that were either too rigid or too invasive in their movement assistance. The benefits of AI-driven exoskeletons are clear. They offer more intuitive and seamless support for people with disabilities or those recovering from injury. The future potential for AI in exoskeletons could extend beyond mobility, incorporating sensors that monitor health metrics such as heart rate and fatigue levels, allowing the system to adjust its assistance for optimal performance and safety. The road ahead: rehabilitation and beyond. While the primary applications of robotic exoskeletons have revolved around medical rehabilitation and injury recovery, there is growing interest in their potential for other fields. In the case of elderly individuals or people with chronic illnesses that affect mobility, exoskeletons could provide essential assistance in maintaining physical independence and quality of life. For people who need to conserve energy during long walks or hikes, robotic exoskeletons can reduce the effort required, allowing them to go further without exhausting themselves. Moreover, the development of modular exoskeletons means that different body parts can be targeted for assistance, allowing for more personalized and adaptive care. For example, people with certain joint or muscle disorders may benefit from specific modules that target only the affected areas. This modular approach is key in tailoring exoskeletons to various needs, further expanding their range of applications. Looking toward the future. As we stand on the cusp of a new era, where technology and humanity begin to merge more seamlessly, it's clear that the potential for human enhancement is limitless. From helping paralyzed individuals regain mobility to allowing athletes to push their physical limits, exoskeletons are just the beginning. These machines offer a peek into a future where our bodies are no longer constrained by biological limitations, but augmented by intelligent technology. The line between man and machine is becoming blurrier every day, and soon, what was once imagined in movies may very well become our reality, whether it's for rehabilitation, performance enhancement, or even just making our daily tasks easier. The future of human enhancement looks brighter and more mechanical than ever before. The question now isn't if we will become cyborgs, but how soon we'll start living that reality. And who knows, maybe one day, the ultimate human experience will involve a little bit of AI and a lot of robotics.